Hi, my name is Lauren Oktovic,
And I'm Katie Letts.
and today we will be demonstrating for you Dragon's Breath, an experiment on electron excitement.
The first step of any chemical experiment is safety. Today Lauren and I have our hair pulled back. We are wearing gloves. We have our aprons on, and we are wearing safety glasses because we are going to be working with chemicals that are potentially toxic, corrosive to the skin, and we are going to be working on open flames.
So next we are going to look at our materials. We're using a meter stick with a candle taped onto it in the hood so that we don't get any of the chemicals anywhere. And then we have 3 different mixtures. They each have 50 milliliters of ethanol, 7.5 milliliters of water, and then in each we have dissolved 1.5 grams of each of the separate salts. This one is copper chloride, this one is lithium chloride, and that one is potassium chloride. So the first step of this experiment is that we're going to light a match and light the candle. Make sure you keep it in the hood so you don't get any of the chemicals or flames anywhere. So first we're going to take the bottle and we're going to hold it a few inches away from the flame, and we're going to spray it onto it. You can see that it makes a bright colored flame as you spray it. This is due to electron excitement. Electron excitement is when an electron jumps from one electron level to a higher electron level and then back down to ground state. As it does this, it emits wavelengths and photons that cause the different color changes and the light changes. For each of these different components, we can see that they each emit a different color. That one was a bright red. You can see that this happens due to the fact that each of the different elements has a different set and different number of electron configurations. And so it'll jump up higher or lower depending on the element. So you can also see that this one has an even different color. It looks just like Dragon's Breath.
Now, Lauren started getting into it, but there's a little bit more theory behind the idea of electron excitement. It depends a lot on where the elements lie on the periodic table and how close they are to hydrogen. Lithium, for example, is the closest out of all 3 of the elements that we used to hydrogen. So it has the most energy to be released, but it doesn't have to go as far to release that energy, so it has a duller flame color. Compared to copper, which is a transition metal and farther away from hydrogen, it has the most energy to be released, and it releases the most amount of energy because it has more outer electrons, so it produces a brighter flame color.
And these we looked and we found all of our sites on the University of Edinburgh and web exhibits. It was really helpful sources that helped us see all the differences between electron excitement and combustion and allowed us to really understand the information, and was very informative.
I'm sure you're all wondering, what is the practical application of something like Dragon's Breath? Sure, it makes a pretty color, but what does it really do? There are 2 applications that we found on the internet. We got both of these from Compound Interest. The first one is the chemistry of fireworks, which implements this exact thing when it burns off the different chemicals that are composed to make fireworks. For example, on the 4th of July, when you have your firework display, you see the red, white, and blue. The red is made by strontium, which burns and releases a red flame. The blue is copper. As you saw here, copper, when it burns blue. And white is magnesium, aluminum, or titanium. Any of those 3, when burned, create a white light. The second application of this is glow sticks. Everybody loves glow sticks. If you don't know how glow sticks work, when you crack them, there's a glass tube inside containing different chemicals, and when it cracks, it reacts with the rest of the mixture inside of the tube, which emits heat, and when that heat is emitted, it excites the electrons in the elements, and it creates all of the different colors of glow sticks that you might see.
Some of the other practical things that you can see that these are used in are things such as safety flares, sparklers. It can even be used in fluorescent lighting or even street lamps. We found all of this information on 3 sources: the University of Edinburgh, Web Exhibits, and Compound Interest. They're very interesting sources. If you'd like to look more, we can have all of these sources for you. Thank you.